Hello, welcome to yet another video on network automation. In this video, we want to show us how AI can be integrated into networks that are built using CICD pipelines. And we will be using this topology where we have two networks, the test network in blue and the production network in green. Over here is the network engineer's machine that has Ansible already installed on it. Ansible will be used as the tool, the configuration tool to configure these devices that we have on the network here. Also on the machine is installed Git, which is going to serve as a version control tool to track the changes that are made on the Ansible code. Now, when the network engineer is done configuring his script, the Ansible code, it will then push it over to GitHub, and GitHub serves as the central repository too. Over here is Jenkins, which is the CICD tool that regularly polls GitHub to check if the network engineer has made new commits. Now, in situation where new commits has been made, Jenkins will then fetch the latest Ansible codes and then use it to, to configure this network. Now, the scripts are usually of two types: the deployment script, which is first executed on the network, and then the second is the test script, which is used to test that all the configurations that were executed worked fine. So in either case, if both of them, both the deployment script and the test scripts work fine, then Jenkins will then execute the deployment script on the production network. But in a situation where either the deployment script or the test script fail, then Jenkins will take the failure report and then use AI to generate what the problem is, and make suggestions on how the problems could be resolved, and then use these two information to send an email down to the network engineer, who will go through the mail and then correct the issue. When he's done correcting it, he's going to push the latest script over to GitHub, and this again will be fetched by Jenkins, and then the process will go on and on until the script is fine, and then will then be successfully executed on the network. So we will just quickly do a live demo on this. Over here is our machine, which is an Ubuntu 2204 network, and here is the playbooks that we have written using Ansible docs. We can immediately see that it is not a flat structure. The directory is not flat, it's modular, and that's because we used Ansible roles to implement it. Now, in the task folder are the playbooks to be executed, and over here is jautomator.yaml, which is the deployment script. All right, so this is the deployment script that will be used to configure the network, and over here is the test script that will be used to test that the configuration of the network is okay. Now, in the host file, we can see that the login credentials for the routers are not hard-coded. That's because we used Ansible vaults, to encrypt the users, the router's credentials. This is the credentials which have been, encrypted using AES 256. Now, to decrypt these credentials, we have this folder here, this file, which is the Ansible vault key, which makes the difference between our local repository and the central repository. This is the central repository, and we can immediately see that we do not have the VPass file in the central repository. This is the VPAR pass in the local repository, but in the GitHub, which is the central repository, we do not have it there. Why? Because this is the key to running the configuration, and this file is therefore manually copied over to the machine where Jenkins is located. So and over here is Jenkins itself. Okay, and this is the CICD pipeline that was developed for it. So we'll just go into the configuration and we can see that every minute Jenkins pulls GitHub to see if there are new commits, and this is the script that will be run for it. So with that said, we can manually click on the build here, but that wouldn't prove a CICD process. So in that case, we will just come over here to our local repository to make some changes so that we can test the failure process in reality. So we will then, so that we can simulate the failure process and see how AI integrates into the total network. So over here, and in order for us to be able to see this early, I'll just change the IP address of the first router. That's, if we look at the topology here, we can see how one is the first router here. So I'll just change the IP address of interface G00 so that we will not be able to SSH into any of the routers. Now, before we go ahead, I want us to confirm what configuration we have running on the network. So show IP interface brief shows us just the basic configurations are running at the moment. Okay, so same thing with this, show IP interface brief. Okay, just the basic configuration, show IP protocol, no routing protocol is running at the moment. Okay, show IP protocol and show IP interface brief, no routing protocol, no configuration IP, just basic interface configurations are running at the moment. So so with that, we will then come back to our folder here and change this IP address. Okay, that's done. Okay, so with that done, I will then I think earlier we made some changes to this. Okay, so that the video will not be too long, we will just correct this back. Okay, and the simulation will be this, and then I'll show us other what's it called, failure results that we have seen in the past, and how AI was used to interpret them. All right, so with that done, I will then use git status to confirm the changes. All right, so the changes, and then add these files to the stage. Okay, and task connectivity. All right, so git commit -m intentional error made on host file to simulate AI in action. Okay, so that's done. Git push, we enter our credentials. All right, okay, so if we check the GitHub now, we would see that this has been updated just now. Okay, just now this was updated, and our this is Jenkins now. Jenkins we can see that the last build is build number 16, so we expect that Jenkins will automatically begin to will automatically sense the commit. All right, so that is the case now. Jenkins has sensed the commit, and in the next few seconds will it has even started, fetching the configuration. So we will just go into the console to see what is going on. All right, so Jenkins tried to log into the port where we changed to 18, and then it failed. All right, and so a mail will then be automatically sent over to bubbling to this address, which we have seen here now. Okay, so we can see that this was at 324. Okay, same as this, and when we check the details we can see that, okay, here it is. So this was generated by Jenkins, but this explanation here was generated by AI. AI was used to generate this part. So now we can see here are some suggestions. This is the error. Okay, unable to connect to port 22 on this. Here are some suggestions. This error is made. This error message indicates that Jenkins server was unable to connect to port 22 on the network this IP address. This indicates that there's a connectivity issue between Jenkins server and the network. Troubleshooting steps. So it gives you some troubleshooting steps. Make sure the Jenkins server is connected to the internet and the connection is stable. Okay. Check the configuration. Make sure the correct IP address and port number are used. And this exactly is the cause of the problem. So ping the IP address, the moment the network engineer pings, he knows that, oh, there's a problem somewhere. So we will then go back to our script. Okay, we will then go back to our script, which is hosts over here, and then correct the code again, and make the push get status. Okay, git add host to update that, git commit. This is just a process that needs to be followed from time to time when the changes are made. Intentional error corrected. Okay, intentional error corrected, git push. And we'll key in the credentials, and that is it. So we will again see, okay, so this is Jenkins over here. When we come here, we go back again, we will see that the latest commit was just made to our central repository. And when we come over to Jenkins, we would see that Jenkins has started 327. So Jenkins has sensed the new commit immediately, and then configuration has started. So now Jenkins has been able to connect. Why? Because we have resolved the issue that was associated to the initial problem. So now execution is going on, and this will, if we go into each of the router, we can see the logs of activities on the router and what exactly is going on. So nothing yet on R3, and on R4 nothing yet, but in a few moments we will start seeing configurations logs going on them. But we can see R1 and R2, the interface configurations are made and the interfaces are up now. So now configuration has started on R3, and similarly on R4 configuration will soon commence. So we can see the entire process. If I come here now, initially we didn't have any interface configured, but when I check, we can see show IP interface brief. So now we have all configuration. We didn't have this two initially, and now we have them included. Okay, so the same applies to um, uh, to uh, router 2 show IP interface brief. Okay, so we can see the initial output we had over here, and then over here is the new configuration after Jenkins, was used to make all the configuration changes. And we can see a tunnel coming up now, and the BGP state between R3 and R4 is up over here. So the configuration is going on, and we can see Jenkins over here still working. But while that is going on, I just want us to see quickly, past failures and, reports that were generated. This is the one that we just, faced now. All right. This is another issue similar to what we had earlier. Okay. And we can see the suggestions also given by AI. Okay, so there are several issues. Okay, so over here we have another type of issue. Okay, so this is about ping. Okay, this is about ping. This IP address was not reachable, and we can see the solution that our AI provided, or not our AI, but integrating with AI, provided. So in this case, okay, great. So in this case, we had a key mismatch, host key mismatch. As a result of that, we had problems, SSHing, and we can see, the suggestion that was given by AI, So all of this help to improve a network engineer's productivity. That is the essence. Instead of a network engineer, running helter skelter, trying to figure out what exactly the problem is, this helps him to nail down what exactly the issue is. So it improves troubleshooting, it improves a network engineer's productivity, and it also saves time. So we can see the ping test running fine. Okay, and by the time we check, okay, so this is R1 running fine, and over here, like I mentioned, after the deployment script was executed, we had to wait a little while so that the network could converge, and that was done. Okay, so after that, the test script was executed, and we can see that for R1 everything was successful. Similarly for R2 as well. So these are all the ping test results, for R1, and for R2 as well, everything ran successfully, and these are all the ping test results, for R4. So, and this is the final result of the ping test for both routers, which were successful, and the total outcome of the pipeline was successful, and an email was sent to this address, which is different from this, to indicate that the entire pipeline was a success. So when we see this is 3:31, and it's against our current time, and it says that the pipeline was successful. Thank you so much for your time, and see you next time. Bye.